I'm here to present to you the chair test of independence using the PSPP. The agenda of this presentation is to again present to you the chair square test of independence using the null and alternative hypothesis using three different samples. We'll state the hypothesis, will reject. We'll present also the rejection and the post-hoc rule along with supporting detail. We'll use the PSPP to conduct the chair test of independence. We examine the outcome, we share the takeaway, and there's also the presentation of the Kramer V interpretation. The first sample is to test the number of cards in relation with the number of defaults. The null hypothesis indicate that there's no correlation between the number of cards and the number of defaults. The alternative hypothesis is that there is a correlation between the number of cards and the number of defaults. So when we run the PSPP test, we notice that the chair square with the depth of freedom, which was 12, the frequency, the number of sample 150, which here was 5.86, and the p value was 0.923 with a Kramer of 0.14. So here with our result, we can determine that the rejection rule is that we do not reject the null because our p value is more than 0.05. So the post-hoc rule is if we do not reject the null hypothesis, then we follow Kramer. And here Kramer indicates that there's a weak relationship between those two values. Therefore, there's no relationship to consider because the Kramer is 0.5 according to the interpretation. Sample tested was the like comfort and the number of defaults. There was no significant result. So our null hypothesis was there's no correlation between the like comfort and number of default. The alternative, there's a correlation between the like result and the number of default. So the chair square with a depth of freedom of 6 with a frequency of 150, the chair square is 6.8 with a p value of 0.351 with a Kramer v value of 0.15 with a Kramer the Kramer value of 0.115 indicate that there is a weak relationship again. So we can conclude that there's no minimum strength needed to claim a relationship. So this also indicates that the result, there's no significant result, meaning no. The third test, where we compare the number of cards and the like comfort, we have a significant result. Where the null hypothesis indicate that there's no relationship between the number of cards and the like comfort. The alternative, there is a relationship between a number of cards and the like comfort. So in this example, the reject rule is we reject the null rule when p the p-value is under 0, it's less than 0.05. Here the p-value is 0. Therefore, the post-hoc rule state that if we reject the null, then we need to follow the Cramer result. So here we have a depth of freedom, which is 9. The number of sample it's 150. The share square is 450 with a p-value of 0. The Cramer rule is 1.00. So this indicates that Cramer has a very strong relationship, and so it's perfectly symmetric relationship. Based on this result, the takeaway of all this, we can conclude that we can use the PSPP to perform the chi-square test of independence. We can perform the test by using analysis, descriptive statistics, and cross-tab. It's important to obtain the Cramer result, which lead us to indicate the strength of the relationship between the variable independent variable that we tested. And the end result of our test was that the test contains some significant and non-significant result. Some of them have, for the significant result, they have a strong relationship, and for the non-significant, some of them have weak and very, very weak relationship among the value that was tested. So that's all we want to present to you today, and thank you very much.